So metals form a giant lattice of layers of positive metal ions, also known as cations, in a sea of delocalized electrons which are free to move around. Here's an example of this type of arrangement. You can see that we have these positive ions and then electrons kind of scattered around the positive ions. Now there is an electrostatic attraction between the positive ions and the electrons, and we call this a metallic bond. And these metallic bonds are usually quite strong. They need a lot of energy to overcome them. That's why metals are very strong and they have high melting points and high boiling points. Now, the way that this metallic bond is structured, the layers of metal ions can slide over each other and there's no disruption in the metallic structure. So what that means is that metals are quite malleable, which means they can be bent, and they're also quite ductile, so they can be drawn into various wiring. Metals are pretty good thermal conductors, and the reason for that is because the electrons can transfer the heat quite well across the metal, and they're also quite good conductors of an electrical current, and that's because these delocalized electrons are free to move around and they can carry the electric current along the metallic structure. One thing to note is that you have metals, but you can also have alloys. So alloys are a mixture of different types of metals. Now, when you have an alloy, these metal atoms which are in this lattice, they can be sized differently, which means that it's harder for these layers to slide across each other because the metals are different sizes. We consider alloys generally to be a lot harder than pure metal structures. So that's just something in addition that you may need to note.